Everyone knows Einstein figured out that nothing moves faster than light. But here's what they don't tell you. The way he got there wasn't some lightning bolt of genius while riding a trolley car. It was darker than that, more disturbing. Because what Einstein actually did was take something everyone thought was true about reality and prove it was a lie. And the way he proved it changed everything we thought we knew about space and time itself. June 30th, 1905. A 26-year-old patent clerk in Bern, Switzerland, submits a paper to Annalen der Physik. Title: On the Electrodynamics of Moving Bodies. The paper runs 17 pages. No footnotes, no bibliography, no citations of experimental data, just pure thought. And buried in those 17 pages is a conclusion so wild that even other physicists will spend decades trying to prove Einstein wrong. Light always moves at the same speed. Always. Doesn't matter if you're standing still or racing toward it at half the speed of light yourself. You measure it, you get 299,792,458 meters per second, every single time. That number doesn't budge. And what gives is time itself. What gives is space itself. What gives is everything you think you know about how the universe works. 17 pages, 891 through 921, published September 26, 1905. And John Norton's analysis in the Cambridge Companion to Einstein, published 2014 by Cambridge University Press, which provides the most detailed reconstruction of Einstein's pathway to special relativity based on Einstein's own 1946 autobiographical notes. Now back to the information. Here's where it gets strange. Einstein didn't start with light at all. He started with a magnet and a wire. That's it. A magnet, a wire, and a question that wouldn't let him sleep. Move the wire past a stationary magnet. Current flows again. Same current, same magnitude. But here's the problem. According to the theory, no electric field exists this time. The magnet's stationary. Instead, the moving wire's electrons cut through the magnet's magnetic field. Different explanation, different physics, same result. The universe was giving two completely different explanations for the same observable fact. And Einstein, in his own words from 1920, said this was unbearable to him. Unbearable. He couldn't accept that reality worked one way from one perspective and a completely different way from another. Because what Einstein realized was that the electric field was relative. Some observers see it, some don't. It depends on your motion. And if electric fields are relative, if they pop in and out of existence depending on who's watching, then something fundamental about how we understand motion and time and space has to be wrong. He later said he first hit on the core problem at age 16, 1896. He imagined chasing a beam of light. What would you see if you could run alongside light, keeping pace with it? Maxwell's equation said light was an electromagnetic wave oscillating through space. So if you matched its speed, you should see a frozen wave, a stationary electromagnetic field hovering in front of you like a photograph. Maxwell's equations don't allow it. Neither does experience. Light doesn't freeze. It keeps moving, always. Maybe light's speed depends on the speed of its source, like a bullet fired from a moving train. That would preserve the principle of relativity, the idea that the laws of physics are the same for everyone. But emission theories created new problems. Light phases would get mixed up. Light might even back up on itself, Einstein told physicist Robert Shankland in 1963. He couldn't make it work. Every physicist in the 1800s believed light needed a medium to travel through, like sound needs air. They called it the luminiferous ether, an invisible substance filling all of space. Light waves rippled through it at a fixed speed. If you moved through this ether, you should measure different light speeds depending on your direction. Moving with the ether, light should appear slower. Moving against it, faster. Albert Michelson and Edward Morley tested this in 1887. They built an interferometer, an incredibly precise device that split a light beam and sent it in two perpendicular directions, then recombined the beams to look for interference patterns. The Earth orbits the Sun at 30 kilometers per second. If the ether existed, that orbital motion should create an ether wind. The light beam moving with Earth's motion should take slightly longer to return than the beam moving perpendicular to it. The difference would be tiny. But Michelson and Morley's interferometer was sensitive enough to detect it. They mounted the interferometer on a massive sandstone slab floating in a pool of mercury to eliminate vibrations. They rotated it. They ran it at different times of day, different times of year. Michelson wrote to Lord Rayleigh in August 1887 calling it a decidedly negative result. The experiment found that the measured velocity was probably less than 1/6 of Earth's expected motion through the ether, certainly less than 1/4. They published in the American Journal of Science in November 1887. George Fitzgerald and Hendrik Lorentz independently proposed that objects physically contract in their direction of motion through the ether, by exactly the right amount to hide the ether wind. The contraction would be tiny, unnoticeable in everyday life, but enough to explain Michelson-Morley. What drove him instead was Maxwell's equations themselves. James Clerk. Maxwell had published his complete electromagnetic theory in 1865 in the paper A Dynamical Theory of the Electromagnetic Field in Philosophical Transactions of the Royal Society. Maxwell's equations predicted electromagnetic waves, and when Maxwell calculated the speed of these waves from purely electromagnetic constants, the permittivity and permeability of free space, he got roughly 300,000 kilometers per second. If you're on a train moving at 50 kilometers per hour and you throw a ball forward at 20 kilometers per hour, someone on the ground sees the ball moving at 70. Simple addition. But if light always moves at 300,000 kilometers per second, then velocities don't add. Not for light. He studied the Fizeau experiment from 1851, where Hippolyte Fizeau measured the speed of light in moving water. The results supported Fresnel's partial ether drag hypothesis, which suggested light's speed depended on the medium and its motion in complicated ways. Einstein later said this experiment influenced him more than Michelson-Morley. When Earth orbits the Sun, the apparent position of stars shifts slightly because Earth's motion combines with the incoming starlight. The shift depends on Earth's velocity and light speed. The math worked if light had a constant speed. It broke if light speed varied with the source. But accepting that meant rejecting something even more fundamental. It meant rejecting absolute time. A cosmic clock ticking away the same for everyone everywhere. If two events happen at the same instant, they happen at the same instant for all observers. Period. But someone on the train sees something different. They're moving toward the front flash and away from the back flash, so the front flash reaches them first. They measure the time it takes light to travel from each strike point. They do the math, and they conclude the front strike happened first. No universal present moment shared by everyone. Einstein laid all this out in his June 30th paper. He started with two postulates. First, the laws of physics are the same in all inertial reference frames. Inertial means not accelerating. If you're moving at constant velocity, you can't tell you're moving. There's no absolute rest, no privileged frame. Second, the speed of light in vacuum is the same for all observers, regardless of their motion or the motion of the light source. From those two postulates, Einstein derived everything. The Lorentz transformations that tell you how to convert coordinates and times between different reference frames. Time dilation, length contraction, the addition of velocities formula that explains why velocities don't simply add at high speeds. This script uses John Norton's detailed analysis published in Archive for History of Exact Sciences, volume 59 from 2004, pages 45 through 105, which reconstructs Einstein's investigations of Galilean covariant electrodynamics before 1905, based on Einstein's correspondence and published papers, proving Einstein seriously considered emission theories before abandoning them. Now back to the information. They orbit Earth at 14,000 kilometers per hour. Special Relativity predicts their atomic clocks tick 7 microseconds fast each day compared to clocks on the ground. Engineers subtract those 7 microseconds. Otherwise, GPS would give wrong positions within minutes. Not because it's physically crushed, because space itself contracts at high velocities. A kilogram of mass contains about 90 quadrillion joules of energy. That's the energy in 21,000 tons of TNT. The atomic bomb dropped on Nagasaki released exactly that much energy by converting about 1 gram of plutonium into pure energy. 1 gram. The power to destroy a city. The Fizeau experiment supported it. Stellar aberration supported it. But Einstein built special relativity on pure thought, on symmetry, on the conviction that the laws of physics must be the same for all inertial observers, on the realization that if light's speed is constant, then time and space must be flexible. Hendrik Lorentz derived the transformation equations in 1892 and again in 1904. Henri Poincaré worked on the principle of relativity and showed in 1905 that Lorentz transformations form a mathematical group. Poincaré even speculated in 1904 that the speed of light might be a limiting velocity if Lorentz's assumptions held. He didn't say the ether exists and objects contract when they move through it to hide the contraction. He said there is no ether. Motion is relative. The speed of light is absolute, and that requires a completely new understanding of space and time. How could simultaneity depend on motion? It violated everything from common sense to 3 centuries of Newtonian physics. He introduced the idea of relativistic mass, the way mass increases with velocity, and showed that a body of rest, mass mu, that absorbs energy, E sub 0 gains, mass equal to E sub 0 divided by c squared. They're woven together into a single fabric. Events don't happen at a place and a time. They happen at a point in space-time. The 3 dimensions of space and 1 dimension of time combine into a 4-dimensional continuum. Away into mere shadows, and only a kind of union of the two will preserve an independent reality. General relativity extends special relativity to include gravity and acceleration by treating gravity not as a force, but as curvature in space-time itself. Massive objects like Earth and the Sun bend space-time around them. Other objects follow the straightest possible paths through that curved space-time. Those paths look curved from the outside. We call that curvature gravity. Special relativity had already rewritten physics. Moving at 99% of light speed, they should only travel about 600 meters before decaying. But muons created in the upper atmosphere, 20 kilometers up, reach the ground. Why? Time dilation. From the muon's perspective, time is normal and it decays in 2.2 microseconds. But from Earth's perspective, the muon's clock runs slow. Its lifetime stretches. It lives long enough to reach the surface. In 1971, physicists flew atomic clocks on commercial aircraft around the world. When they landed, the flying clocks had gained time compared to stationary clocks on the ground, exactly matching special relativity's predictions to within experimental error. They measured the mass of a silicon atom before and after absorbing a neutron and releasing gamma rays. The mass difference matched E equals mc squared to 9 decimal places. At 100 kilometers per hour, time dilation is about 1 part in 10 trillion. Unmeasurable without atomic clocks, but it's there, always. But here's the part people miss, the part that reveals Einstein's real genius. Constant. And if light's speed is constant, then time and space can't be absolute. They have to transform between observers in specific ways we can calculate. It meant Maxwell was right and Newton was wrong. Not about mechanics in the everyday world. Newton's laws work fine at low speeds, but about the fundamental structure of space and time. A second is only a second relative to someone at rest with respect to the clock. Move fast enough and meters shrink and seconds stretch. Instead, the universe has a cosmic speed limit, 300,000 kilometers per second. That's not just the speed of light, it's the speed of gravity, the speed of any massless particle, the speed of causality itself. At 99% of light speed, your mass is about 7 times your rest mass. At 99.9%, it's 22 times. At 99.99%, 70 times. The closer you get to C, the more energy you need to go faster. At C itself, your mass would be infinite. You'd need infinite energy. Can't be done. 0 times infinity can equal any finite number. For photons, it equals their energy divided by C squared. But anything with even a tiny rest mass can never reach C. Always. He didn't measure it. He didn't derive it from more fundamental principles. He recognized it as fundamental itself, an axiom of nature. And once he accepted that, everything else was just mathematics, inevitable, inescapable. That experiment had been too puzzling, too troublesome. It found nothing where something should have been. Morley, who died in 1923, also remained skeptical. They'd proven the case against the ether. They just couldn't abandon the worldview they'd grown up with. The building at Kramgasse 49, where Einstein worked from 1902 to 1909, where he examined patent applications for electromechanical devices by day and rewrote physics by night. There's a plaque now, a museum. Tourists take photos. That the speed of light is the one absolute in a relative universe. The magnet and conductor showed him that electric and magnetic fields are relative. That pushed him to think about simultaneity, about time, about what it means for 2 events to happen at the same instant. Only the invariant speed of light connecting them, because nothing with mass can move at light speed. The geometry of the universe, the relationship between space and time and mass and energy, it's not a place, it's a limit, an asymptote, the edge of what's possible for anything with mass. From Maxwell's equations and the principle that physics must be the same for everyone. That contradicted 300 years of accepted physics. And if those laws require time to be relative and space to contract and mass to increase with velocity, then that's how it is. That made Einstein world famous overnight, the man who proved Newton wrong about gravity. Light speed is constant because space-time is structured that way, because the universe has geometry, and in that geometry, the interval between 2 events, the space-time distance, stays the same for all observers, but space distance and time distance trade off. What one observer sees as pure space, another sees as a mix of space and time. What one calls simultaneous, another sees as sequential. The paper didn't mention ether drift experiments, didn't cite Michelson and Morley, barely referenced Maxwell. Einstein built special relativity from first principles, from symmetry, from thought. Not because he happened to guess right, because he understood what light's constant speed actually means. He didn't flinch from the implications. He followed the math. At the Swiss Federal Archives in Bern, you can request to see the original 1905 manuscript, 17 handwritten pages, dense script, minimal corrections. Einstein wrote it out almost complete in 6 weeks, once he'd seen the answer. Time and space absolute, give up Newton, abandon the ether, accept that reality depends on the observer. The galaxy moves through space relative to the cosmic microwave background at 2.1 million kilometers per hour. Einstein killed that idea by showing there is no true frame. Motion is fundamentally relative. If different observers disagree about when events happen, about how much time passes, about lengths and distances, different observers slice through space-time at different angles. Their slices, their present moments, cut differently, so they include different event sets. The space-time structure is absolute. What's relative is how you slice it, how you separate space from time, where you draw now. The formula s squared equals c squared t squared minus x squared minus y squared minus z squared stays the same for all observers. That's invariant. Those paths form the boundary between events that can influence each other. The light cone structure, past and future defined by what events can signal what other events. Signals propagate at c. Faster than light signals would reach regions that are in the past of some observers. Causal loops, effect before cause, grandfather paradoxes, causality collapses. Once you accept that, special relativity isn't theory, it's mathematical theorem. Given the postulates, same laws for all inertial observers, invariant light speed, Lorentz transformations follow necessarily. Time dilation follows, length contraction follows, velocity addition follows, E equals mc squared follows. He knew it was right before anyone tested. The logic was airtight, the mathematics rigorous. If the postulates were true and evidence suggested they were, the conclusions had to be true. Charge to mass ratio decreased, mass increased. By 1915, everyone accepted moving objects gain mass. They live longer. From the muon's frame, Earth's atmosphere is length contracted. Both explanations correct. Same physics, different frames. Eastbound flights lost 59 nanoseconds on average. Westbound gained 273 nanoseconds, matched special and general relativity predictions within error bars. Every GPS satellite tests special relativity. Satellites orbit at 20,000 kilometers, moving at 14,000 kilometers per hour. Special relativity says their clocks should tick faster by 7 microseconds per day. General relativity says clocks at higher altitude tick faster by 45 microseconds per day. Combined, 38 microseconds per day fast. Without correcting, GPS would accumulate 10 kilometers error per day. The system compensates, works, because special relativity is right. Researchers directly tested E equals mc squared, measured silicon-28 mass before and after absorbing a neutron and emitting gamma rays. Mass difference, 8.6 times 10 to the minus 6th atomic mass units. Gamma ray energies totaled 1.414837 MeV, divided by c squared, 8.6 times 10 to the minus 6th atomic mass units. Perfect match to 9 significant figures. E equals mc squared verified at precision beyond Einstein's dreams. Second, missing 4 million tons become energy, light streaming into space. E equals mc squared powering every star. About 1 gram of plutonium mass converted to energy. Yield, 22 kilotons. Fireball, 300 meters diameter. Einstein's equation proven in fire. Conservation of energy and momentum demanded. In a universe where light's speed is constant. Heat a pot of water, you increase its mass. Tiny amount, few nanograms for boiling water, but measurable, real. In relativity, mass is a form of energy, rest energy. And energy changes form. Heat becomes motion, becomes light, becomes mass, becomes any other form. Nothing fundamental except energy. And energy only makes sense relative to a reference frame. Everything else, mass, energy, momentum, time, space, length, simultaneity, relative, dependent on observer's motion. The willingness to follow logic even when it leads somewhere impossible. The speed of light isn't just a speed, it's the conversion factor between space and time, between mass and energy, between what is and what could be,